here's what we're going to do. We're going to take a function f from the set of d by d matrices to the set of d by d matrices. And f is actually going to be a very simple function. F of a matrix A is just going to be equal to a squared. So what we're going to do is show that this function is differentiable. So how can this function be differentiable? In fact, how do we take the derivative of a matrix-valued function? Well, you kind of define it in the same way that we always define derivatives. df at A is equal to the limit as some matrix H approaches the zero matrix, which looks like this, of course. And that's important because if you multiply any vector by it, it will give you the zero vector of a plus h squared minus a squared multiplied by h inverse. Okay, pretty simple. So now we expand this. And you might first think it's a squared plus 2ah plus h squared, but don't go off muscle memory. The only reason this works with regular numbers is because regular numbers, well, commute. But matrices don't commute. So it's going to look more like this. So subtracting a squared from that mess gives us ah plus ha plus h squared times h inverse. Or, in other terms, a plus h plus ha h inverse. Now let's show that, for example, it's differentiable at the identity matrix. So df of the identity is just equal to the limit as h approaches 0 of the identity plus h inverse, which is just the limit as h approaches 0 of the identity plus h, which is just 2 times the identity. Or okay, so that's a pretty simple way to show that this matrix-valued function is differentiable at the identity matrix. Now you can show a few other things, including using the inverse function theorem to show that an inverse exists, but we'll do that next time. Thank you